Okay, guys, in this lesson, we're going to learn how to simplify radicals. We were learning how to estimate, but this time we are going to give a more precise answer. So most of our answers will have a radical still in the answer. So again, one of the first things you need to know is your perfect squares. So make sure you have memorized these are the perfect squares that we will use most often. Now, you still need to know these, but the first column are the ones that will be used the most. And remember, when you take the square root of a perfect square, you get back its root with no radical left. Let's take a look at the parts of a radical expression. So here we have the coefficient, which is the number on the outside that is multiplied by the radical expression itself. This A is your index. Remember, it tells you how many times the radicand was multiplied to get that value. And the number or expression under the radical symbol is called the radicand. So this whole thing is a radical expression, and here are the components. Now remember, when we're taking the square root, our index is a 2, and if it's missing, it's understood to be a 2. And also recall that the radicand, the number underneath the radical, has to be a positive number when we're taking square roots. So let's recall our inverse operations. This will help show what taking the square root actually means. So we know that in order to undo addition, such as the problem here, we would subtract. So addition and subtraction are inverses. They undo one another. Multiplication, we would use division. And with division, we would use multiplication. So now we have learned a new operation, which is squaring. If we square 6 squared, we get 6 times 6, which is 36. And remember, we have learned that when we take the square root, it undoes something that's being squared and we get back the root. So let's start with our very first problem, square root of 48. Now, we are not going to estimate this. We're not going to find what perfect square comes before and what perfect square comes after. We're doing something totally different. We're not getting a decimal here. So the first thing that you need to do is to find the largest perfect square factor of 48. So what I mean by that is we are going to rewrite 48 into two factors that give us 48. Now 48 has several factors and we can list those. So 1 times 48, we can have 2 times 24, we can have 3 times 16, and we can have 4 times 12. So these are all factors of 48, and we're going to rewrite the radicand with one of these pairs. Now keep in mind, our perfect squared numbers is the list that you're going to have in the forefront of your mind when you're simplifying radicals. Now I'm not putting 1 there because 1 will not be helpful in breaking this down. So we have 2 perfect squared factors of 48. We have 3 times 16 gives us 48 and 4 times 12. And what we're trying to do, guys, is take the root of the highest number that we can. So 3 times 16 is going to be a better choice because 16 is larger than 4. Because if we chose 4 and 12, you would see later on that 12 could factor even more. It's kind of like when you have, let's say we have 12 over 24. Let's just go back to something we know. We could simplify this by a factor of 2 and get 6 over 12, but we can see we can still simplify. So the better choice would have been 12. If we would have simplified by 12, we would have got directly to the 1/2. The same goes true for simplifying radicals. You want to choose the largest perfect factor of that number. So now I'm going to take the square root of 16, which is 4, and then I'm left with radical 3. And 3 cannot break down anymore. So this is your answer for radical 48. Radical 48 is equal, not approximate, but is equal to 4 radical 3. Now let's try a few more. Again, you're going to keep these numbers in mind, and this is what we want to use. We're going to try to break down 24. So 24, I'm not going to use 1 in 24, but we have 2 times 12, we have 3 times 8, and we have 4 times 6. And the pair you want to pick is the one that has a perfect square, which is going to be 4 times 6. The square root of 4 is 2, so you bring it on the outside of the radical, and you're left with radical 6. Now, I know that 6 can break down into 2 times 3, but 2 and 3 are not perfect squares, so you are finished. Let's look at 50. We have 1 and 50, which is not very helpful. We have 2 and 25, and 5 times 10. We can see that we're going to use 2 times 25, or I like to put the perfect square first. That's just my preference. I'm going to take the square root of 25, which is 5, and then I'm left with radical 2. Let's look at 12. We have 2 times 6, and we have 3 times 4. Obviously, we're going to use the 3 times the 4 because 4 is a perfect square. When I take the square root of the 4, I get 2, and I'm left with radical 3. 80. So we're going to break down 80. So we have 2 times 40. We have 4 times 20. Rewrite that. We have 5 times 16. And I think that's all. And you can see that 4 is a perfect square, but also 16. So this is your better choice. 16 times 5 is 80. When I take the square root of 16, I get 4 and then radical 5. Now let's take a look at a few more. So let's look at 18. So I have 2 times 9 and 3 times 6. Well, 9 is perfect, so we're going to choose 9 times 2. I take the square root of 9, which is 3, left with radical 2. 75. 25 times 3 is 75, and 25 is perfect. When I take the square root of the 25, it gives me 5, and I'm left with radical 3. 20. We have 2 times 10, but that doesn't help because they're not perfect, so we have 4 times 5. The square root of 4 is 2, radical 5. 27. We can break down 27 into 9 times 3. The square root of 9 is 3, radical 3. Now we have some that have coefficients already here. This just means 5 times the square root of 12. So that means we're going to simplify radical 12 first and then multiply the root by 5. It's kind of like parentheses. You do this first. So we bring down the 5. We're going to break 12 into 4 times 3. The square root of 4 is 2, times 5 is 10, radical 3. Here we have 32, so I'm going to list these out. So we have 2 times 16 and 4 times 8. 4 and 16 are both perfect, but 16 is a better choice. The square root of 16 is 4. 4 times this 3 that's already there is 12, radical 2. We just did 27 on the previous page, 9 times 3. The square root of 9 is 3 times this 2 is 6, radical 3. And we did 20 earlier, so that was 4 times 5. The square root of 4 is 2. 2 times 4 is 8, radical 5. Now we have some unit fractions. Unit fractions means our numerator is 1, so we're really just going to be dividing by that denominator. We have 9 times 3. The square root of 9 is 3, so we have 1/3 times 3, radical 3. Our 3's cancel out, leaving us with 1 radical 3. Notice I didn't put the understood 1 there. Just leave it as is. We have 1/4, and we're going to have 4 times 2. The square root of 4 is 2, and 1/4 times 2, put that over 1, radical 2. So we're going to simplify this. So 1 times 1 is 1, 2 times 1 is 2, radical 2. And we have 200. So 100 is a perfect square. So 100 times 2. The square root of 100 is 10. So 1/2 of 10 is going to be 5. So we're going to have 5 radical 2. We have 1/3. We're going to break down 45. Okay, 45 has, we can use 9. 9 times 5. The square root of 9 is 3. 1/3 of 3. The 3's will cancel, so we're just going to be left with 1 radical 5. Okay, pause the video and you try these. When we come back, we'll do them together. Okay, 54 can break down into 9 times 6. The square root of 9 is 3, radical 6. Now, 98, I'm sure that took you a little while, but it is 49 times 2. The square root of 49 is 7 times 2 is 14, radical 2. We just did 200, so 100 times 2. That gives me 10 times 3, 30, radical 2. We have 1/2. We'll break this down into 4 times 7. The square root of 4 is 2, and times 1/2 gives me 1, radical 7. We're going to do 4 times 3. The square root of 4 is 2. 1/2 times 2 is 1, then radical 3. And then we have 1/3. Okay, 108. So that's 36 times 3. The square root of 36 is 6. 3 goes into 6, 2, and 1 times 2 is 2. So we have 2, radical 3.